to learn some of those patterns. And then polynomial and rational inequalities. Polynomial inequalities not so hard. This isn't necessarily hard. It is just new to you, especially the rational inequalities and like the logic of why we do what we do with those. But anyway, in general, solve and graph a solution set on a real number line for 2x squared plus x is greater than 15. This is a quadratic inequality. So just like you would with a quadratic equation, you want to get it equal to 0 or greater than 0 in this case. So if I subtract over the 15, I'm essentially looking for where this parabola is positive, right? Greater than 0, that would be positive, yes? So you guys obviously know with parabolas, whether they're pointing up or pointing down, when do these parabolas become, when do they go from being positive to being negative? Around what critical points? Aiden?
The zeros.
The zeros, right. So if you look at the one that's right side up, for example, it's positive, aka above the x-axis. Then you reach a 0 and it goes negative. And then you reach another 0 and it goes positive again. Below the x-axis, above the x-axis. So obviously there's a point of transition surrounding the zeros. It doesn't have to be a point of transition though, just to be clear. Here's a 0. It's positive prior and it's positive after. So there are cases where it can be positive on both sides of the 0. Or it can be negative on both sides of the 0. But if it cuts through the x-axis, it's obviously positive on one side and negative on the other. So we still want to find our zeros because those are our critical points. So we're going to factor. And what we're really interested in are those zeros, because those zeros are going to give us different intervals in and around which we should test for whether or not the function's positive or negative. So one of those is at 5/2, and one of those is at -3. So when I go to plot these, is 5/2 in and of itself going to be a location that's greater than 0? If 5/2 is a root, is that going to be greater than 0? No. If you're a root, you're actually not positive and you're not negative. So you're not greater than 0, you're actually equal to 0. If this was a greater than or equal to sign, I would say yes, 5/2 works. But 5/2 will not give you something that's greater than 0. It will give you something that actually equals 0. So when we plot 2.5, we're going to do it with an open circle. And then -3, same thing, open circle. And so now we have 2 roots will give us 3 intervals in which we have to check. So we're going to check, and this is where you guys did do number line tests last year. We're going to check something over in here. -4 would be easy. My recommendation is plug it in to here, because we don't really care about the actual number. We just want to know, is it positive or negative? So if I plug in -4, 2 times -4 is -8. -8 minus 5 is, I don't care what the actual number is. I know it's a negative though. Times, if I plug in -4 here, -4 plus 3 is a negative. And a negative times a negative is a positive. So is a positive greater than 0? Yes. So if that worked, we shade it in. And all of those are solutions. If I plug in 0, I'm going to get a negative times a positive. Negative on the first factor, positive on the second. A negative times a positive is a negative. Is a negative greater than 0? No. So that section does not work. So I put an X through it. And then something greater than 2.5, let's say 3. If I plug in 3, I'm going to get a positive times a positive, which is a positive. Positives, yes, are greater than 0. So that works. So that number line test is one method. The other method you guys could use, if you know your zeros and you know this graph opens up or opens down based on the leading coefficient. Does it open up or does it open down? Positive 2x squared. Up, right? So if you picture a parabola that opens up using those roots, when is it above the x-axis? All the way over here and all the way over here. That's why we shaded in those directions. If you wanted to base it off of your knowledge of the graph, you could do either. Does that make sense? So your solutions are partially shown by the number line, and then you'd actually explicitly state what they are in set builder notation. That would be the set of all x's, such that x is less than -3 or x is greater than 5/2. Interval notation, that would be -infinity to -3, and its union with 2.5 to infinity, or you can use 5/2 again. I don't think we really need to look at this quadratic on the graphing calculator, because I already told you the point that I would make is that we have roots here and here, and it's opening up. So when is this positive? When is this above the x-axis? And it's from -3 back to -infinity and 2.5 to positive infinity. Okay, so then upping the ante to a cubic polynomial. Same deal as with equations. We want to get it equal to 0 first. Find the roots. Hopefully grouping works. It does. Because I really don't want to do my P's over Q's. Although I will if I have to. But this is groupable, so we can avoid the other method of factoring, which is long division. And then we pull our x plus 1 out, and we're left with x squared minus 4. And we can factor that further into x plus 2x minus 2. Any questions so far? So the roots around which we're going to test our intervals are -1, -2, and 2. Are those numbers, those roots in and of themselves, solutions to this polynomial having to be less than or equal to 0? Yes, these are, because we have the or equal to symbol. So -1, -2, and +2 all will get closed circles. And again, we can now do the number line test. 3 roots is going to give us 4 different sections to test. Yes? So we can test all of those, or I can remind you about a positive odd starts how, ends how. Positive odd. Nate? Right. So, and we don't have any double roots, so we're going to go straight through, and straight through. So if you kind of treat this like the x-axis, we are looking for when this is less than or equal to 0. So over here, is this a good solution? Is this less than or equal to 0? Is the graph underneath the x-axis over in this section? Yes, it is. So that's going to work. Meaning if we had plugged in -3, it would have worked. How about if we plug in anything in between -1 and -2? Is that less than or equal to 0? No. It's above the x-axis. So that would be greater than 0. So we don't want that. Andrew, you made me nervous. What were you confused by there? Just a mistake. Okay. Over here, again, if you feel more comfortable plugging in a number like 0, by all means, I'm just trying to give you different options. Anything in here is below the x-axis, so it is negative, and we want this to be negative because it's less than or equal to 0. So this section will work. And then over here, we're above the x-axis, so that section will not work. So our solutions, and let's go interval notation, are negative infinity to negative 2, this time with a bracket on the negative 2, union with negative 1 to 2. Good? All right. So polynomials, whether it's a quadratic or a cubic or a fourth degree, polynomials simply change from positive to negative surrounding roots. Yes? And that's going to be true for any function. But with other functions, there may be other opportunities for a jump. For example, in rationals, obviously, let's do it this way. I'm just going to make up a graph. Don't draw this. But let's pretend this is my graph right here. Let's pretend this is at 2 and that the asymptote is at 4. Is the graph positive or negative here? Okay, right, that shouldn't be a tough question. That means is it above the x-axis or below? So it's definitely above the x-axis. So it's positive here, and then we hit a 0, and it becomes negative, yes? So just like with our polynomial functions, we have a change from positive to negative surrounding a root. That's always going to be the case. And again, sometimes it could bounce off of that and it could remain positive, but it's worth looking at. It's a critical point. It's worth looking at. And so then we're negative, negative, negative pretty much forever. And when we hop to the other side of this vertical asymptote, all of a sudden we're positive again. So the additional stipulation with a rational is that around an asymptote, you also have the potential to change from negative, which we are on the left, to positive, which is what we are on the right. Does that make sense? So your critical points for your number line don't just come from roots when it comes to a rational. They come from the roots, and they come from wherever your asymptotes might, your vertical asymptotes might be. Okay? So critical points come from roots and come from vertical asymptotes. And you have to test in and around both of those. So, to get this thing started, just like polynomials, we do need it to be equal to 0. So I'm going to subtract the 2 over. Not only that, but I need to get this into a strictly rational function. Not a rational function that's getting shifted down to, right? To get it to be a strictly rational function, we have to do the subtraction to make this a single fraction. So that's going to require getting a common denominator. So this needs an x plus 3. This needs an x plus 3. My numerator is going to become x plus 1 minus 2x minus 6 all over x plus 3, which is going to become negative x minus 5 over x plus 3. And guess what? They're probably not going to leave it negative x, negative 5. They'll probably factor out a negative 1 and just do x plus 5. Does that make sense? That's going to be a lot easier for you to, number 1, find the roots. And number 2, when we start testing numbers, it's going to be easier for you to check in that capacity there than with the negative x minus 5. So, where is our root? Roots come from the zeros of the, starts with an n, ends with numerator. Numerator. So your roots come from the zeros of the numerator. So we have a root at negative 5. Now, at the root, would that qualify as being greater than or equal to 0? Yes or no? In other words, am I going to use an open circle or a closed circle? At the root, will it be greater than or equal to 0? Yes or no, John? Yes, because roots are equal to 0. So that's a closed circle. Our vertical asymptotes come from the zeros of the denominator, which is -3. This is a different conversation. At an asymptote, is the graph greater than or equal to 0? Mitch, what are your thoughts on that?
Greater than 0.
Look up here. Right at this asymptote, at 4, in this random example that I drew, is the graph negative or positive there?
At 4?
Yep.
Positive?
Nope. It's a trick question.
Oh, it's neither.
It's neither, right?
Yeah.
It's not equal to 0 like a root is. It's not positive and it's not negative because, quite frankly, the graph does not exist there. So if the graph does not exist there, there's no way an asymptote produced critical value is ever going to be a solution. Okay? It doesn't matter if that's using an equal sign or not. That came from an asymptote, and we do not equal 0 at an asymptote. We're not positive. We're not negative. We are neither. Does that make sense? So don't fall for like, oh, it's greater than or equal to, so let me make them all solid. There's a little more thought behind this one when you come from an asymptote. That logical work will work for roots, but not for asymptotes. All right, so let's check this. If I plug in a -4, we'll start in the middle. -4 plus 5 is a, what kind of number? -4 plus 5 is a positive. But with a negative out in front, that numerator is a negative over, what's -4 plus 3? Also a negative, right? And a negative over a negative is a positive. Is a positive greater than 0? Shade that in. Check 0. 0 plus 5 is a positive. Positive times a negative is a negative up top. Over 0 plus 3 is a positive. A negative divided by a positive is a negative. Is a negative greater than 0? No. And then -6. -6 plus 5 is a negative. With a negative out in front, that'll actually turn that to be a positive. And -6 plus 3 is a negative. Positive divided by negative is negative. Is a negative greater than 0? No. There's our solutions. So we don't really know too well what this function looks like, so I'm going to show you. X plus, x plus 1 divided by x plus 3 minus 2. So essentially we're looking for where was this graph positive? Just from -5, yes? Up until but not including -3. And that's what we got, right? Because -3 was the asymptote. So that would be from -5 with a bracket to -3 with a parenthesis. Any questions? Oh boy. We need some zip. There's a little zip in this class. Morgan, can you read that for me, please?
A ball is thrown vertically upward from the top of the Leaning Tower of Pisa, 190 feet high, with an initial velocity of 96 feet per second. During what time period will the ball's height exceed that of the tower?
I need a visual. Anybody ever been to the Leaning Tower of Pisa? Nobody? I was just trying to look for an opportunity to talk about something that wasn't math related, but never mind. I've been, though. I went with my college soccer team. I sure did. We went to Italy, and we went to the Leaning Tower of Pisa. Among other places, but that was one. I don't have any good story about it. If I can, I'll try to bring in a picture of myself there in the year 2003. Can you imagine? That was 15 years ago. Okay. So here's what we got. It's 190 feet tall. So this is height. And I'm throwing a ball upward. And then, of course, it's going to fall. So we have something that's parabolic. And I don't know if you guys have realized this over the years, but anytime you have like something that's thrown up in the air, or it's thrown off of a cliff, or it's shot from a rocket from the ground or something, your leading coefficient has always been negative 16. Have you noticed that? That's a physics thing, right? Accelerate, something about the acceleration due to gravity. I'm looking at Abby because she looks confidently like, yep, I know that.
Well, we haven't gotten that far in physics, but kind of.
Okay.
Well, yeah, it's always negative because when you throw something up, it decelerates.
Right.
And it goes back down.
Right. It's always negative, but I think it's always negative 16 or
It's
something like that.
the rate of gravity is 9.81.
What's so funny, Andrew? Mackenzie, what's going on over there? His phone's on his desk. Andrew?
No.
Andrew, put it away. Okay, we'll put that away. Tweedledee and Tweedledum up there. Trista, are you over your little issue? Or no, are you still mad at her? Yeah.
No, we're not friends anymore.
Ugh.
Oh, yeah, we're.
That'll do it in high school. Just one comment, Done and over with. Friendship over. Anyway, that is almost always negative 16. The details surrounding it, you'd have to ask your physics teacher because I kind of forget. The coefficient of the middle term is the initial velocity of whatever it is that's being thrown or fired. Because obviously, if the initial velocity is super fast, you're going to get a steeper curve, right? Does that make sense? And if it doesn't have much velocity, it's going to turn around faster, essentially, and be kind of a flatter parabola. So V sub 0 is an initial velocity. So when they tell us 96 right here as the initial velocity, we need to plug that in. And then S sub 0, S in physics and in math is the position for these types of things. So the initial position essentially is also the y-intercept, which is the starting height, right? Your initial position is how many feet off the ground?
190.
190. Good. Who said that? Good job, Mitch. He's just trying to move this along. It's a slow Monday. Now, question is, during what time period will the ball's height exceed that of the tower? Meaning, at what time will it exceed 190? So when will this exceed 190? Is essentially what we're solving. Does that make sense? And so, just like on the front side, solving a quadratic inequality, we still get it equal to 0. So subtracting 190 from both sides is an easy thing. I would say you're probably going to solve this by factoring, right? GCF of negative 16t, which leaves us with t minus 6. And then we have critical values at 0 and at 6. Which should make sense. Because look at your 190 line. This is, we didn't know it was going to be 6, but this is happening after 6 seconds. So for the first 6 seconds, and we have the visual in front of us, so we really don't need to do a number line test. It says exceed. So do we want an open circle or a closed circle here? Open, because it's not technically greater than 0 there. It's technically not exceeding 190 if it's at 190. Same thing at the 6 second mark. So during what time period? Between 0 and 6 seconds. Any questions on that? There's your homework. You want to start it? You can start it.